Welcome back. This is an Aleks homework video on using the maximum work theorem with chemical work. Okay, I like this problem. You've got some sugar and it gives you the free energy of that glucose as it's being broken down. Then it tells you how much energy it takes to assemble a peptide bond on a protein, and that you have 62 amino acids. That means you have 61 bonds. And then so how many glucose molecules are going to use in order to make this protein. So the title of this problem is using the maximum work theorem. Okay, so we have to use the maximum work theorem. The maximum work theorem is essentially how much of the free energy changes, and that's how much work can be done. So if you think of free energy, it's the available energy to do something with. So that's really the money you have to spend to do the work with. So they're going to say that you've got a negative delta G. All right, so you've got you're turning glucose into carbon dioxide and water, which reaction is spontaneous because it's negative here. Once you have that amount, how many of these proteins can you, or how many moles or grams of these proteins can you do? Let's see, calculate mass of glucose. So find moles and then find out how many grams that you're going to need to do it. All right, so first of all, I've got 62 amino acids. That means I've got 61 bonds. It tells us that it's 21 kilojoules per mole in order to join it together. So that's the work that's being done. And then it also tells me that I've got 250 micromoles of this protein. So don't be tricked. Make sure you put it into moles so that everything cancels. Okay, so that's 2.5 times 10 to the negative 4 moles. And then the work that I need to make those 61 bonds is 0.32 kilojoules of energy. Okay, so that's what I'm going to do. Now, I've got 2872 per glucose molecule. Now, you have to be careful because don't put that negative there. The negative told me that its change in G was negative, which means it's spontaneous. But the amount of energy that I had to burn, the amount of energy that I had to make peptide bonds with, was the 2872. Okay, and it's per mole because it was 1 mole of sugar that broke down. So that's what here I have 2872 kilojoules per mole, and then I divide that out. How many of these am I going to need? Divide by that number, and I see that I've got 1.1 times 10 to the negative 4 moles, so just a little bit. And then I'm going to use that moles to find grams with. So we go back to chapter 3, and we find that we have that many moles to do it. We're going to multiply by the molecular mass, and I would always look this up on Aleks if possible, or just Google it, but I'm always afraid of the number of significant digits for him. Aleks, I think of him as a mean guy. So when I cancel moles and end up with grams, I've got 2 times 10 to the negative 2, and then so I simply just take it out of the scientific notation, and it's 0.020 because they asked for 2 significant digits. So I need that second 0, otherwise it'll be wrong. Grams of glucose. So kind of an involved question. Interesting, I think. You may like it, you may hate it, but hopefully you'll get it right every time.